Good morning, ladies and gentlemen. Welcome to week 7 of your SAT Prep Math Plug Time sessions. This week we're discussing some stuff that we have talked about here recently in your geometry course, the triangle angle sum theorem, and your transversal rules, such as corresponding angles, linear pairs, vertical angles, those sorts of things. The geometry on the SAT is very general, but they do expect you to remember a fair amount of your geometry rules by the time that you hit your junior year. So again, before we get into the examples here, please make sure that you've written your complete first and last name on the line so that I can clearly tell who the paper belongs to. Circle your teacher's name and what course you are in. If you are in more than one course and have more than one teacher, then feel free to circle more than one. Okay, so here we go. Example 1, in the figure to the right, lines L and M are parallel lines. So L and M are parallel lines. Y equals 20 and Z equals 60, which means this is a 20-degree angle and this is a 60-degree angle. It says, what is the value of X? Well, we would need to know two rules in order to complete this problem. The first rule would have to be that we would have to know that these two angles, the two I've marked with the highlighter, are corresponding angles, which means that this angle is also Y degrees, which is 20 degrees. So, here we have a triangle, and the sum of the angles in any triangle must be 180 degrees, which means X degrees plus Y degrees plus Z degrees has to be 180 degrees. Now, we were told in the directions that Y is equal to 20, so we're going to put that in there. And we were told that Z is equal to 60, so we're going to put that in there. And that will give us an equation that allows us to solve for X. So X plus 20 plus 60 equals 180. Combine like terms, and then subtract 80 from each side, and we get that X is 100. X is 100. Again, that requires a combination of us knowing the corresponding angle postulate, which says if lines are parallel, like L and M, then corresponding angles must be equal. And the angle sum theorem for triangles, which says the three angles in any triangle, in this case this triangle right here, have to add up to 180 degrees. The SAT will generally draw a picture for you, and it will almost always say figure is not drawn to scale. That is because you're not supposed to trust the picture in terms of acute and obtuse angles. You're just supposed to trust the rules and the math. Okay, the things that you know to be true, like the corresponding angle postulate, the angle sum theorem, stuff like that, are what you worry about. You don't worry about whether or not the picture looks correct. Okay, on example 2. In the figure to the left, three lines intersect at point P. If X equals 65 and Y equals 75, what is the value of Z? So the things we need to realize here is that we have a pair of vertical angles here, which means that this top angle here between angle X and angle Z must also be equal to angle Y. Now the other hard part here is realizing that these three angles together add up to form a straight angle. So it's similar to the last problem in that we end up with an equation. X plus Y plus Z has to add up to 180 degrees. We would then go in here and plug in 65 for the X value and 75 for the Y value and solve for Z. So 65 plus 75 plus Z equals 180. Add like terms, 65 plus 75 is 140, and then subtract 140 from each side of the equation, and we get Z equals 40. Again, it just requires us to know our basic geometry rules. Okay, example 3 is going to be a little bit harder, but not a lot harder. It says in the figure to the right, AD intersects BE at point C. So AD and BE are line segments. If X is equal to 100 degrees, what is the value of Y? So the way that this works is that we have to figure out this angle here first. Okay, so the measure of angle ACB is one of three angles in that triangle. So our first step would be to figure out this angle here, angle ACB. ACB. So we'd plug in the 100 for the x from the directions, which would give us the measure of angle ACB plus 100 plus 20 equals 180. And we would solve for the measure of angle ACB. So we'd add like terms, which would be 120. And then we would subtract 120 from each side. And we would get that that angle, this angle here, is a 60-degree angle. The measure of angle ACB is 60 degrees. Now the reason why we care is because if that is a 60-degree angle, then vertical angle theorem says that angle ECD is also a 60-degree angle, which then allows us to set up a second equation. Y plus 40 plus 60 has to equal 180 degrees as well, which is me adding up the angles in triangle CDE. So that would be, again, add like terms, y plus 100 equals 180, so y has to be 80, because we would subtract 100 from each side to solve for y. So y is 80. Okay, finally in example 4 it says in the figure to the left, segments AE and BD are parallel. If angle BDC, that's this angle here, BDC, measures 58 degrees, let's try to get a smaller pen, maybe that will help here, measures 58 degrees, so this angle here is 58 degrees. Okay, that is angle BDC. And angle ACE measures 62 degrees. So ACE, boom, 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 that's this angle here. That angle measures 62 degrees. It says, what is the measure of angle CAE? CAE is the angle we're trying to find. So we would start off with the parallel line segments, AE and BD, and we have to recognize that because those are parallel line segments, we have to know that this angle here is corresponding. Angle DBC is congruent to angle CAE because they are corresponding angles. So these are both x degrees, which allows us to set up the triangle angle sum theorem. X plus 58 plus 62 is equal to 180 degrees. Again, just like the others, we're going to add like terms. X plus 120 equals 180. And then we are going to subtract 120 from each side, which will give us that angle that we're trying to find, angle CAE, is a 60-degree angle. Okay. So once again, on the back of this worksheet are several examples for you to try on your own. Please try those examples and then turn this paper into your proctor. Please show all of your work so that we know what you are thinking. Thank you very much once again for your time and attention, ladies and gentlemen. Enjoy Thanksgiving break, and I will see you after break.